Hello everyone, welcome back to another important video of the DSS series. So today we are going to solve one of the most important problem of the DSA. So let's start it. So first we understand what is the problem actually. So so the problem is the row with the max ones. So this is the problem of the digits for digits. So we are given a 2D binary array consisting of only ones and zeros. Each row of the array is sorted in a non-decreasing order. Our task is to find and return the index of the first row that contains the maximum number of ones. If no such row exists, then return -1. So the question asking about that we have given a 2D matrix, 2D binary matrix. Each cell contains either 1 or 0, and both the rows in the matrix are contains the element in a non-decreasing order, means in increasing order. So our task is to find out the row which contains the maximum number of 1, and we have to return their index value. If no such row exists, then in that case we just need to return -1. There is no, the array follows zero base index as the array is following zero base index, and the number of rows and columns in the array are denoted by n and m respectively. So let's understand this person with the example. So see here there is a 2D matrix here given. So as the answer is given 2. Why 2? Because see here the first row contains 3 number of ones. The second row contains 2 ones. The third row contains 4 ones. And the fourth row contains 0 ones. So out of 4 row, the maximum number of 1 contains by row 2. So that's why the answer is uh, row 2 index. So let's try to solve this question. So let's move. So see, I have taken one example, okay. So what is the first brute force approach to solve this question is that we will iterate each and every row, and each row we will find out the number of ones. After that we will keep one variable which will track the maximum number of ones we got so far. As well as also we take another variable index. Let's take variable max, which will track the maximum number of one which we got so far in a row. And we will also take another variable called index that will keep track of the row which got the maximum number of one. So at the first row we will find out, we will calculate the number of one in this row. So 1, 2, 3. So there are three row. There are three row in the first. There are three one in the first row. So far we have got three row. Sorry, three ones. And where we got three ones in the first row, which index is 0. Again we will calculate. We will calculate in the second row. Now the here will calculate the number of ones is 1. And what we do here, we just simply, here we got 2 1 in the second row. Now we will identify, is it greater than the maximum number of row, maximum number of 1 which we got so far? No. Maximum number of 1 which we got so far is 3, and we got in 0th row. So we will not update it. Again we will iterate in the third row, and we will calculate the number of 1. So 1, 2, 3, 4. In the third row, we got the number of 1 is 4, so that we will check that maximum number of 1 which we got so far is 3. So do we need to update it? Yes, we have to update it. So just we update the index as well as maximum number of one which we got. So the maximum number of one we got is 4, and where we got an index 2. Again we will iterate. In the last row the number of one is 0, and but the maximum number of one we got is 4. So as we reach the end of the row, so there is no any further row is left which we have to traverse. So as the answer we got maximum number of 1 is 4, and where we got at index 2 means the row third. So just we need to return its index. Now the final answer is 2. So this is what we got. So the like a brute force approach which comes in mind is that we will iterate each and every row. After that, we will track the maximum number of one as well as the index where we got. And at the end, we will return the index where we got the maximum number of one. So I hope this approach I hope this explanation helps to understand the question. So let's try to write the code. So this code see here to save the time I have already written the code here. So I will explain each and every line of this code. So we have given one matrix which contains either 0 or 1. So I have initially calculated the n which will uh, point the number of row and m which will point the number of column. I have taken two pointer, the max count which will track the maximum number of maximum number of one which we got so far, and index which will point the where we got that maximum number of one in which row. So initially I have exit this for loop will execute the all the number of rows, will execute rows 0 to till last row. Inside this for loop, I have taken another variable current count, which will count the number of one which we got in this current row. This loop will execute all the column in this current row, and whenever we got the cell value as 1, so we'll increment the current count value. At the end, if we got the current count is greater than the max count, so in that case we will update the max count as well as we also update the index, means where we get this maximum number of 1. So when all the row has visited at the end, we will simply return the index where we got the maximum number of 1. Let's try to run this code. Yeah, so this code runs successfully. Let's try to submit it. Yeah, so this code has successfully passed all the test cases. Let's try to understand the time complexity to solve two of this approach. So as here we are taking two nested for loop. So the total time complexity will be order of n, where n is the number of row, and m, where m is the number of column. So this is the total time complexity to solve this problem. And if I have to talk about the space complexity, as we don't need to, as we are not taking any extra space, so the space complexity is order of 1. Can we optimize? Yes, we have to optimize it, because in the interview they might be asked you to optimize this solution. So how can you optimize it? So let's try to understand the question once again. So we have given a 2D matrix, right? And each row are in a sorted order. So whenever there is something which are in sorted order and we have to find out something, so in that case binary search work perfectly and efficiently. So here we have to find, as we have to find out the rows which contains the maximum number of, one, right? And all the column are in a sorted order. So definitely we have to traverse each and every row, but we can reduce traversal of all the columns. So how can we do it? As if, let's see that if we can able to find out the left place where we got the first one, then you can easily tell that the number of one in this current row, right? See here in this example, if somehow we can able to find out the left place where we got the first one, definitely from that we can calculate the number of one percent in that row, right? So how can we do it? We'll iterate. Let's see here. The first row we got first cell. In the first row, the first cell where we got the first one is the index one, right? So from here, if we uh, like subtract from the number of column, so the number of column is four, right? So if we subtract four minus the index, which is one, so definitely we can tell the number of one which we got in the first row. So here three, yes, definitely one, two, three. So there are three number of one in the first row. So the formula is simple. What we can do here, we just need to calculate by if we put n minus the index where we got the first row. So here we can say that the number of one, right? So let's try to execute it. Yes, in the first row we got three number of one. In the second row we got the first one at index two. So then the two minus four is definitely be two. So this yes two is the number of one. At the third row, where we got the first one, which is at index zero. So 0 minus 4, you have 4, which is in the number column, minus 0. 4 minus 0 is 4, definitely. So yes, the number of 1 is 4. At the last row, we haven't got any 1. So definitely it will point here, the index will point minus 1. So definitely there is no any 1 is there. So out of all, the maximum row, the maximum one which present at index 2. So this is the answer. So let's try to understand how we can implement the binary search, right? So let's see here, how can we implement the binary search? So let's try to understand how we can implement the binary search. So see here, let's assume that we are at row number 0, right? We are at the row number 0. So what we will do here at row 0, just initialize the two pointer low and high. So low will point to the 0 and high will point to the last column, which is n minus 1. And we have taken another pointer which is I, which will point to the first index where we got the first one. Now, as for the binary search like code, while we execute this while loop until low less than equal to high, At the first, we like calculate the mid, which is low plus high divided by 2. So let's assume that the low is pointed to at this place and the high will point to this place. So at the initially we got the mid at index 1, right? So we will calculate. Yes, we got. Yes, we'll find out. Here we'll check. Is this cell means the matrix of row 0th row and mid is 1 is equal to 1? Yes, this value is 1. So yes, so what we do here, we simply update this I, means yes, we got the index where the value is 1. So we update the I, as well as we'll also update the window size. Now high will point to mid minus 1. Mid is 1, so high will point to here at the place 0. So what here, like a low and high both are pointed to here. Again we will find out the mid. Low plus high divided by 2 is both all are pointed to here. Now the mid is at index 0. Now check matrix of row mid equal to 1, no, its value is 0. So this if will not execute, the else part will execute, right? So now we will update the low equal to mid plus 1. Now the mid will point to index 1 because the mid is pointing to index 0, so low will point to index 1. As low and high both are swapped to each other, means low is 1 and high pointed to 0 index. So this loop will execute it. After that, we will got the current count of 1, which is nothing but m. M is the number of column. I is pointing to the first one index in the row, which is nothing but 1. So now the current for the row 0, the current count of 1 is 4 minus 1 is 3. M is 4 and I is 1, which is nothing but 3. In a similar way, we will do for rest of the row, and at the end we got the second row as the answer because it is containing a maximum number of 1. This is the binary search which I have shared with the pseudocode to all of you. Let's start to code this approach. Yes, so let's to save the time, I have already written the code. So I will explain each and every line of the code so that you can easily understand the code. So the first step I have initialized n, which will point the number of row in this matrix, and m, which will point to the number of column in the 2D matrix. I have taken two pointer like a max count, which will count the number of 0, and index, which will point the row which containing the maximum number of 1. This loop will execute all the row. I have also taken two pointer uh, current row and I, which will initially current row is initially initialized with the 0 and I is initialized with the -1. I will keep track where we got the first one in this row. See here we have taken another two pointer low and high. So low is less than equal to high, right? So this loop will execute. This is the binary search. Okay. So low will less than equal to high. Okay. Firstly, we have calculated the mid, which is nothing but low plus high divided by 2. If that currents mid, if the current cell is equal to 1, it means that we got the index where the value is 1. So we'll update the I, as well as we update the window size. Now high is pointing to mid minus 1. If somehow we haven't got the 1, if the middle index value is pointing to 0, in that case, we will update the loop. At the end, when this loop will execute, if the entire row doesn't contain the any one, it means that I will still point to -1. So in that case, we don't have to do anything. The current count which is the remain 0 because this row does not contain any one. If it is not in, it means that at least at least single one is there in this row. So in that case, we will update the current count. What will be the value of the current count is m, which is pointing to number of column, and I is which is pointing to the index value where we got the first one. Here we'll check if the current count of 1 is greater than the max count of 1. Definitely we will update the max count, as well as we also update the index. We'll also update the index that where we got the maximum number of 1. At the end, when we visited all the row, so we just simply return the index value where we got the maximum number of 1. Let's try to solve this. Let's try to compile and run this approach. Yeah, it has. Let's try to submit this code. I'm sure that it will pass all the test cases. Yes, so it has successfully completed all the test cases. So this is about binary search. So let's understand what is the time complexity of this approach. So as here we are like iterating all the row. So definitely the time complexity is order of n because we need to iterate all the row, and each row we have to identify the we are implementing the binary search, right? Each row we are not traversing all the column. We are implementing here binary search to searching the specific position where we got the first one. So to do that, we need to compare or check only log n number of element, log m, right? Where m is the number of column. So this is the optimal solution, that it is only taking order of n into log m, where n is the number of row, and log m where n is the number of column. So this is the optimal solution. And if I thought about the space complexity, so still it is taking a constant space because we are not using an extra space. So this is the optimal solution for this problem. So I hope this both the approach clear to you. So thank you so much for watching the video, and I will come back with another important video of the DSS series. Till then, bye bye, take care. Thank you.